Greetings. So, categorical syllogisms, a part of our introduction to logic module. Alright, doing this because a lot of persons are having difficulties with this area. So, let's go. So, categorical statements. The first thing is to understand that these are statements that put items in categories or not. Right? So, with each categorical statement has a subject and it relates it in some way to a predicate category. So the subject category we just call it S for short, and the predicate category we call it P. So we have four standard forms of these statements. So all S are P. So all of the subject category are members of the predicate category. Right? This is one. We call it the A statement. Next we have the E statement, which says no subject or predicate. So none of the members of the subject family or category are members of the predicate category. That's the E statement. Then we have the I statement, which says some S are P. So some members of the subject category are members of the predicate category. And then the last one, or O statement, says some S are not P. So some members of the subject category are not members of the predicate category. Alright, so let's go. So we have our, notice it's A, E, I, O, no U, since it's 4, A, E, I, O. So, stylistic variants. Stylistic variants are just other ways of saying the same thing. So each categorical statement, each standard form, has other ways of representing. So for the A statement, all SRP. Other ways that are not standard is when persons say every S is a P. So every member of the subject category is a member of the predicate category. We could standardize this by just saying all S are P. Each S is a P. Each member of the subject category is a member of the predicate category. Any member of the subject category is a member of the predicate category. If anything is a member of the subject category, then it's a member of the predicate category. Things are only members of the subject category, or things are members of the subject category only if they are members of the predicate category. And last one that's a little trickier is only members of the predicate category are members of the subject category. So if you notice, this one has the predicate before the subject. So when we say only, then we have to be careful, right? Because if we're looking at a girls' school and we say only females attend the popular girls' school in Montego Bay, right? Only females, so the predicate is females, and the subject is the popular female high school in Montego Bay. Now, if we were to standardize that, we'd have to switch around the subject and predicate. And we'd say only females attend the popular girls' high school in Montego Bay. So all members of the popular girls' school in Montego Bay are females. Right? That's it. Right? So I just got twisted with that because I didn't write it down. I was just going off script. Yeah. But if we have only PRS, it is always switching around subject and predicate. Right? And we're going to look at some examples as we go along. So similarly, we have no SRP. Other ways, non-standard ways of saying this is nothing that is a member of the subject category is a member of the predicate category. A thing is a member of the subject category only if it is not a member of the predicate category. If anything is a member of the subject category, then it is not a member of the predicate category, and so forth. Right? Some SRP, stylistic variants. Some SR not P, some stylistic variants. Right? So you can always pause to look at this to get an idea of some of the ways that these things can be said. Well, let's jump in. So the quality of a categorical statement is either affirmative or negative. So affirmative means you're saying yes. You're saying yes, this subject is included in the predicate category. And our two affirmative standard form statements are the A statement. All members of the subject category are members of the predicate category. Or the I statement. Some members of the subject category are members of the predicate category. So these are affirmative. They are saying, yes, the subject is included in the predicate. Then we have the negative statements. So the negative statements are the opposite. They are saying, no, the subject is not included in the predicate category. Right? So examples are our E statement and our O statement. So our E statement says no members of the subject category are members of the predicate category. O statement, some members of the subject category are not members of the predicate category. So that's quality. Now quantity, right? Quantity is either universal or particular. So universal says it applies to all members. So it's either the A statement or the E statement. So it's either all or none. For particular, it's some. Some are or some are not. So it's our I statement and our O statement. So that's quantity. Now, where we really want to get to, and this is where persons have a little difficulties with the Venn diagrams. So, for Venn diagrams, the shaded area shows the section of the subject circle that is empty, like a wasteland. Nobody lives there. Right? So this section is empty. All members of the subject circle would be in the unshaded section. So the circle has many sections, and we're saying any part that is shaded is known to be empty. So for all SRP, the A statement, right, we're saying if all members of the subject category are members of the predicate category, that means all members of the subject category are here in overlap between the two. So if all the members are here, then it means the rest of the circle is empty. So shade that section to show that it is empty. Right? And the other one, for no SRP, we know that there's no overlap. So if no members of the subject category are members of the predicate category, that means there's no overlap between the two. So we can shade the overlap to show that it is empty. Right? So the shading only applies to our universal statements. A statement or E statement. For the particular statements, we use an X. And X marks the spot, like a treasure map. Right? X marks the spot where some members of the subject circle are located. Right? So the X says we know that some members are here. Right? And that's either inside the predicate circle or outside. So watch this. Some members of the subject category are members of the predicate category. That's the I statement. So if we are saying some are inside the predicate circle, we put the X in that section of the subject circle that overlaps with P. If we are saying some of them are not P, then we put the X in the section of the subject circle that is not overlapping with P. Right? So this applies to our particular statements, the I statement and the O statement. So steps to determine validity. 1. Draw the Venn diagram for the premises. 2. Draw the Venn diagram for the conclusion. 3. Compare both diagrams. They should be giving you the same message. Right? In fact, there are some persons who don't even draw the Venn diagram for the conclusion because they do the comparison straight from the premises diagram. So the argument is valid only if both diagrams are conveying the same message. Right? So if the message of the conclusion is seen in the premises diagram, then the argument is valid. An example. Premise says no laypersons are priests. Right? So first thing is laypersons, subject, priest is a predicate. So subject, predicate. And if it says no laypersons are priests, that means there is no overlap between the two. So we're going to shade the overlap section. Right? So this would be that. The conclusion says, so all laypersons are non-priests. Now, many people go wrong with this because if you started with a premises diagram with laypersons and priests, then your conclusion diagram also have to have the same laypersons and priests. You have to be consistent. Right? So if it says all laypersons are non-priests, all laypersons are non-priests, that means you're saying that all laypersons are outside of the priest circle. So that means that the overlap between the two would be empty as well. Right? All laypersons are non-priests. That means they're over here in the section that does not overlap with priests. And this would be it. So it would now be incorrect to have laypersons, non-priests, and then shade over here. Have to be consistent. So the same labeling must be there. And this is valid. Here's another one. Some chairs are not thrones. So we have chairs, we have thrones. If it says some chairs are not thrones, that means we're going to put an X over here in the chair circle, but outside of the throne circle. So some members of the chair circle are not in the throne circle. Conclusion. So some thrones are not chairs. So notice, even though thrones come first and chairs come second, we have to be consistent. It's chairs, thrones. So the conclusion diagram must also have chairs and thrones. But this one now says the subject is thrones. So subject is thrones, and it says some members of the throne circle are not in the chair circle. So here we're going to put an X outside of the chair circle. So is this valid? No, it is not. These are conveying two different messages. So invalid. Alright, so syllogisms now. We're taking it a step further. For categorical syllogisms, right, these are arguments made up of three categorical statements regarding three categories or terms. So a syllogism is generally a three-step argument, a three-statement argument. So a categorical syllogism is a syllogism with three categorical statements. Right, so here goes. The three terms are the minor term. The minor term is the subject of the conclusion. The major term is the predicate of the conclusion. So you know the conclusion has subject and predicate. So the subject of the conclusion is our minor term. The predicate is our major term. And then we have the middle term. The middle term is the one that appears in both premises, but it's not in the conclusion. So the middle term appears in both premises, but not in the conclusion. Right? That. Alright, so looking at this syllogism, no millionaires are poor persons. Some actors are millionaires. So some actors are not poor persons. So first thing is, before we even start identifying the terms, well, yeah, we can identify. So the conclusion. The minor term is the subject of the conclusion. So that's actors. The major term is the predicate of the conclusion, which is poor persons. And then the middle term is the one that appears in both premises but not in the conclusion, and that would be millionaires. Alright? So, should be able to identify our terms. Now, three guidelines for the standard form. 1. Each statement must be in standard form. There must be either an A statement, an E statement, an I statement, or an O statement. Standard form only allowed. 2. Once we identify the major term should be in the first premise. And 3. Oh, and that first premise will now become what we call our major premise. And 3, the conclusion must be stated last. So 3 guidelines for the standard form, right? And then each statement must be in standard form. The major term should be in the first premises, and the conclusion must be the last statement. Now, mode of the argument. So once we have ensured that the syllogism is in standard form, meaning it meets the 3 guidelines we just established, then we can identify the mode and figure. So for the mode, it's just a list of vowels representing the order of the 3 standard form categorical statements. Right? So no millionaires are poor persons. What type of statement is that? That is, no S, no subject or predicate. Correct. That's an E statement. Second term. Second statement. Some actors are millionaires. Right? Some S are P. That's an I statement. And in our conclusion, so some S are not P. That's an O statement. So the mood of the argument is E, I, O. Right? An E statement followed by an I statement followed by the conclusion, which is an O statement. E, I, O. E statement, I statement, O statement. Now, I already verified that this is in standard form. Remember the three guidelines? The major term. So the major term is the predicate from the conclusion, poor persons. The major term should be in the first premise. So we're good with that. Oh, the first condition was that each statement must be in standard form. Yeah, and each of these are in standard form. We already established E, I, O. The major premise is in the first. The major term is in the first premise, and the conclusion is stated last. So we are good. This syllogism is in standard form. Alright, so we have the mode. Next, we should be able to identify the figure of the argument. The figure is based on the position of the middle term in the two premises. So, figure 1. The middle term appears first in premise 1 and second in premise 2. Now, this is our figure 2 argument. The middle term appears first, so it comes as a subject, then it appears as a predicate, first, then second. Right, that's figure 1. Figure 2. The middle term is second in both premises. Right, so the middle term, millionaires, no poor persons are millionaires, that's a predicate here. Some actors are millionaires, that's a predicate again. So millionaires appears second in both premises, which makes this a figure 2 argument. Then once you know these two, figure 1 and figure 2, figure 3 is just the opposite of figure 2. So for figure 2, the middle term is second in both. It means in figure 3, the middle term would be first in both. So, no millionaires are poor persons, some millionaires are actors. It's a subject in both premises. So that's figure 3. And last, figure 4 is the opposite of figure 1. Right, so technically you just need to know figure 1 and figure 2, and the others flow from that. So figure 1 says the middle term should appear first in premise 1, then second in premise 2. So that means the opposite would be middle term would appear second in premise 1 and first in premise 2. So it's like they're rearranged. So middle term, second, then first. That's figure 4. Right, so that's a figure of the argument. So, Venn diagrams now. Because there are 3 terms, we need 3 circles. But the circles must be put in the right order, or else this thing is not worthy of examination. So, order of the circle, essential. The top circles represent the conclusion. So, the subject term, the minor term, is on the left from the conclusion. On the right, we have the predicate term from the conclusion, that is our major term. Alright, so minor term, major term, subject from conclusion, predicate from conclusion, that's at the top. And then the lower circle, the bottom circle is our middle term. Right, so the order is essential. Examples. So I want to do some Venn diagrams. So remember, the shaded area shows the section of the circle that is empty. And when we're doing our Venn diagrams, right, we have 2 premises, but we always complete the universal premise first, since that's going to have a shaded area that shows us that it's empty. So all S are M. One example. So all members of the subject circle are members of the predicate circle. Oh, middle circle. No. Right, so all S are M. So all members of the S circle are members of the M circle. Right, so if you are in the S circle, you're also in the M circle. You're in this section which overlaps between S and M. So that means if all members of S are in this overlapping section, that means the rest of S circle is empty. Right? So everything in the S circle outside of these sections will be empty. Now, some persons get confused because they're looking at the P circle, but just remember, technically, each argument, each statement has two terms. When we're doing the Venn diagram, we focus on the two terms that are being referred to. So this refers to S circle, M circle. So for all intent and purposes, we can pretend the P circle is not there. Alright, don't get confused by the P circle. Focus on S and M. Alright, next, no S or M. So no members of the S circle are members of the M circle. That means there's no overlap between S and M. And again, don't be confused by the P circle. We are saying there's no overlap between the S circle and the M circle. Another one, all M are S. So all members of the M circle are members of the S circle. So that means if you're in the M circle, you're in the overlapping section, you're in the section where it overlaps with S. So that means that if you're in the M circle, you're in this overlapping section, which means that there's nobody in this other section. Right, so this other section is empty. Because if you're in the M circle, you're in the section where it overlaps with S. Right, so these are some examples. Look at not some more. All P are M. So these are the P circle and the M circle. All members of the P circle are in the section where it overlaps with M. That means the rest of the P circle is empty. Another one. No P are M. That means there's no overlap between P and M. And remember, don't be distracted by the S circle now because we're dealing with the P and M. And all M are P. All members of the M circle are in the section where it overlaps with P. That means the rest of the M circle is empty. Alright, X marks the spot. So, two premises now. All S are M, some P are M. So first, all S are M. Alright, so if you are in the S circle, you are over here where it overlaps with M. The rest of the S circle is empty. Then some P are M. Some members of the P circle are members of the M circle. So some members of the P circle are in the section where it overlaps with M. So if you realize there are two numbers here, 5 and 6. Where do we put the X? Is it in 5 or 6? We don't know. Because all the premise says is that some members of the P circle are in the section where it overlaps with M. So here we would put the X on the line, the borderline, to show that we're not saying it's in 5, we're not saying it's in 6. Or we know that it is somewhere in the overlap between P and M. No SRM. Oh, and looking at this, what conclusion should we be able to draw from these two premises to see if the argument is valid? Right? Now, technically, the conclusion would be between the two top circles. Because the conclusion is between the minor term and the major term. So, what could we draw as a conclusion from this? And for this one, we couldn't really draw any conclusion. We couldn't say all members of the S circle are in the P circle because that's not true. Right? There are some members in the S circle that are outside of P. And we couldn't say that no members of the S circle are inside the P circle because here we have some members of the S circle as well. And then this line is not inside S. So we couldn't say that it relates between S and P. So I couldn't see no conclusion here. So any argument using these two premises would be an invalid argument. Look at this one. No SRM. No overlap between S and M. So we'll shade the overlap. Some members of the P circle are inside the M circle. So look at this now. Some members of the P circle are also in the M circle. So we're going to put an X. But this section, number 5, is empty. So that means the X has to go in section 6. Right, so this would be here. Again, what conclusion could we draw from this? I don't really see any conclusion here. Well, yes, technically, there is a conclusion here. Right. This is saying, look at the x. There's an x in the P circle that is outside of the S circle. So, yeah, but this would really be a conclusion because the conclusion would be related to S. So if the conclusion was that some P are not S, that would be invalid. But the conclusions wouldn't be stated that way. The conclusions start with the minor term, then the major term. So no, any argument with these two premises will be invalid. Alright, look at some more. All S are M. Right? So all S are M, all S are in overlap between M and S. Everything in S, empty. All M are P. So if all M are P, that means everybody in M is where it overlaps with P. So we shade this part that is empty. Now, what conclusion can we draw from this? Everybody seeing it? All of the S circle is shaded except section 5. Where is section 5? It's inside a P. So that means that if you are in the S circle, you are in this little section where part of where it overlaps with P. So the conclusion here, a valid conclusion would have been all S are P. If you are in the S circle, you must be in the section where it overlaps with P. So all S are P would be a valid conclusion. Got this one. No S are M, no M are P. So no S are M, right? So that means that there's no overlap between S and M. No M are P. So no M are P, that means no overlap between M and P. What conclusion do we have here? I don't see any clear conclusion. Right? Because we don't have the X's to say it's a particular statement. And we need to have the overlap is not fully shaded between S and P. And the outside here is not fully shaded either. So no clear conclusion. So argument from this would be invalid. Argument with these two premises, invalid. Look at this one. All M are S. So if you are in the M circle, you are where it overlaps with S. So that means that we're going to shade the part of M that is outside of S. And it says some P are M. Some P are M. So some members of the P circle are in the section where P overlaps with M. So the only empty section here in the overlap is 5, so put the X right at 5. Now what conclusion could we draw from this? There's an X in the overlap between S and P. So some S or P would be a valid conclusion. Right, so if we had an argument with these two premises and the conclusion, some S or P, valid. Got this. Some SRP, some MRP. Right? So SPM. So some SRM, that means there's an X in the overlap between S and M. Now, where do we put it? Don't know, we have to just put it on the borderline. I did these with the numbers to show that you can do it without the numbers as well. Right? Some MRP, that means some members of the M circle are inside the overlap with P. Where do we put it? Don't know, we have to put it on the border here. Because we don't know how it relates to S. What kind of conclusion? No clear conclusion. Some S are not M. Some S are not M. So some members of the S circle are outside of the M circle. That means the X must be outside of M. But we don't know if it must be here or here. So we just put it on the border. Some M are not P. Some members of the M circle are not members of the P circle. Right? So that means they are outside of P. Don't know where, so we'll put it on the border. What's the conclusion? No clear conclusion. Some M are not S, some P are not M. So some M are not S. That means some M are outside of the S circle. If I put it on the line, since we don't know exactly where. Some P are not M. Some members of the P circle are not members of the M circle. So some members of the P circle are outside of M. We have to put X on the border since we don't know exactly where. Right? And of course, again, no clear conclusion. So note, always work on the universal premise before the particular premise. If argument has both, that is, shade the empty area before you add an X. Alright. Next, we're going to do a video from a tutorial sheet. But this one, not sure if it will be public as yet. So let's wait and see. Blessings and all the best.